Chapter 6, Lesson 1 is powers and exponents. In the warm-up, it says here, Claire used counters to make the patterns shown below. We want to know how many counters will be in the next two figures. Okay, so if we look at these, okay, let's look at these as figure 1, figure 2, figure 3, figure 4, figure 5. Okay, so this is let's call this figure 1, and this one is figure 2. This one is figure 3. This one is figure 4, and this one is figure 5. How many counters do we have in the first figure? 1. How many figures do we have in the second figure? 4. How about the third? 9. Okay, now if you look at those numbers, okay, what kind of pattern do you notice? So if you look at this, we have, if I multiply figure 1, if we multiply 1 times 1, we're going to get 1. For figure 2, if I take 2 times 2, what am I going to get? 4. If I multiply figure 3, 3 times 3, what am I going to get? 9. Does everybody see that? So what do you think I'm going to multiply for figure 4? 4 times 4. And what do you think I'm going to multiply for figure 5? 5 times 5. So that tells me that in figure 4, how many are going to be there? 16. 16 counters. And how many counters will I have in figure 5? 25. Is everybody clear with that?
Yes.
Okay. So here we have 16 counters and we have 5 counters. And of course, here you can even, when you look at the counters, you can see 2 times 2, right? Here, 3 times 3, 4 times 4, and 5 times 5. Okay? So the next question here is how many counters will there be in the 12th counter? Okay? So if I'm looking at, in the 12th figure. So if I'm looking at figure 12, what will I multiply to get the number of counters? 12 times 12. So we're going to multiply 12 times 12, and that will give us 144. Very good. Very good. Is everybody clear with that? So you can look at the counters, you can look at the patterns, and you can figure out some kind of formula to find out what your future pictures are going to look like. All right, so here is your vocabulary setup. Please make sure you write down these vocabulary. The base is the number used as a factor. The base is the number used as a factor. The exponent tells how many times the base is used as a factor. So here in our warm-up, when we were multiplying each of those counters, we're multiplying 3 times 3, 4 times 4, 5 times 5. The base, or the factors, were those 3, 4, 5. Here, if I have 10 times 10, 10 is the factor. You see that? And when we write it as a power, the base is 10. Okay? So, 10 times 10, those are factors. How many times did we multiply 10 times itself? Twice. So, that tells me that that's what my exponent is going to be. The exponent tells you how many times you are going to multiply the base times itself. Okay? So, when we write 10 to the second power like this is called a power. So here, numbers expressed using exponents are called powers. That's why 10 to the second power is called a power. Okay? Here it says, for example, 100 is a power of 10 because it can be written as 10 to the second power. 10 to the second power. So now we're going to write products as powers. Okay, so 100 is a power of 10 because it can be written as 10 to the second power. Numbers like 100 are called perfect squares. Now, a perfect square, make sure you write this definition down too. A perfect square are the squares of whole numbers. Okay, a perfect square are the squares of whole numbers. So, when I say the square, okay, does everybody see this 10 to the second power? That means 10 times 10, right? That is a special name for a power. This, we would say 10 squared. Is everybody with me? Because we're multiplying 10 times 10 twice. So here we've got 10 times 10, that gives me 100. That 100 is going to be a perfect square. So for example, 4 is a perfect square because 2 times 2 is 4. 25 is a perfect square because 5 times 5 is 25. You see? 16 is a perfect square because 4 times 4 is 16. Is everybody clear with that? How about some other perfect squares? Tell me. Go ahead. So 36 is a perfect square because 6 times 6 is 36. What's another one? So 81 is a perfect square because 9 times 9 is 81. Yes? 12 times 12 is 144. So 144 is the perfect square, not 12. You see that? All right. 49, good. 100, good. They said yours? 81. Did we say 81 already? So, when we're multiplying a number times itself twice, that will give us the perfect square. Okay? Perfect cubes are numbers with 3 identical whole number factors, like 4 times 4 times 4. Okay? Make sure you write down that definition. So 64 is a perfect square because 4 times 4 times 4 is 64. 8 is a perfect square because 2 times 2 times 2 is 8. So here in example 1, we want to write 6 times 6 times 6 times 6 using an exponent. So here the base will be what? 6, because the base is the number that's getting multiplied times itself, right? And how many times did we multiply it? 1, 2, 3, 4 times. So the exponent will be 4. So 6 times 6 times 6 times 6, written as a power or written using an exponent, is 6 to the 4th power. So for example 2, we want to write 4 times 4 times 4 using an exponent. So here, the factor or the base is which number? 4 times 4 times 4, 4, right? Now, the factor is multiplied how many times? 4 times 4 times 4, that's multiplied 3 times. So that means that my exponent is going to be 3. Very good. So 4 times 4 times 4 can be written as 4 to the 3rd power. Very good. So for the got it's, please make sure you write down your original problem. Here for letter A, for problem A, we have 7 times 7 times 7 times 7. Okay? So what's my base going to be? 7. The base is the big number that we're multiplying times itself, right? So, and now, how many times did we multiply 7 times itself? 4. So 4 is going to be the exponent. So this is going to be 7 to the 4th power. All right, so here we have 9 times 9 times 9 times 9 times 9 times 9 times 9, right? So what's the base going to be? 9. Very good. And how many times did we multiply 9 times itself? 1, 2, 3, 4, 5, 6, 7. So my exponent is going to be 7. So now we're going to write powers as products. Make sure you write down your heading. Okay? To write powers as products, we want to determine the base and the exponent. So remember, the base is the big number. The exponent is the little number in the top right-hand corner. The base is the number that is getting multiplied, and the exponent tells you how many times it's getting multiplied. Okay? So, here are some special names for some powers. Okay? Here we have 10 to the second power. If we have 10 to the second power, that special name is squared. So when the exponent is 2, you can say to the second power, or you can say squared. Is everybody clear? If your exponent is 3, so if we have 10 to the third, we read that as 10 cubed. So if your exponent is 3, then it's cubed. So, for example 3, it says write 5 squared as a product of the same factor. Then find the value. So here, ladies and gentlemen, is where you will multiply it out. So here, 5 squared is 5 times 5, right? The base is 5, the exponent is 2, so we're multiplying 5 times itself twice. So 5 times 5 is 25. This is where you're going to evaluate to find the final answer, okay? You can also use decimals, okay? So here we have 1.5 to the third power, or 1.5 cubed, and we want to write that as a product of the same factor, and then find the value. So here, 1.5 cubed is written as 1.5 times 1.5 times 1.5. And then when you multiply them out, you get 3.375. Please make sure you know how to multiply decimals. Okay? And we can also do them with fractions. Okay? So here we have 1/2 cubed. 1/2 cubed, or 1/2 to the third power, means 1/2 times 1/2 times 1/2. So here we've got 1/2 times 1/2 times 1/2. And if you multiply the numerators, 1 times 1 times 1 gives me 1. And 2 times 2 times 2 gives me 8. Is everybody clear with that? Now there's another way that you can do this. I'm just going to tell you real quickly. Here, if I have 1/2 cubed, okay, you can also write 1 times 1 times 1, which is 1 cubed, right? And then 2 times 2 times 2, which is 2 cubed. Is everybody with me? So, if I simplify that, 1 cubed is 1, and 2 cubed is 8. So what we're noticing here is that 3 gets applied to everything inside the parentheses. So, for these got it problems, it says write each power as a product of the same factor, and then find the value. Okay? So, 10 to the 5th power, we write as 10 times 10 times 10 times 10 times 10. Very good. Is everybody clear? Now, we want to find the value. So here, of course, if they're all 10s, can I just multiply 1 times 1 times 1 times 1 times 1? And that gives me 1. And how many zeros am I going to add on there? 5. So this is going to be 1, 2, 3, 4, 5, 100,000. So for problem D, we have 2.1 squared. So 2.1 squared, if I want to write that power as a product of the same factor, what am I going to write? 2.1 times 2.1. Very good. Now, when I have decimals, I don't like to do the dots because there's too many dots on the page. So I use the X for the multiplication when I'm doing decimals, okay? And then 2.1 times 2.1 is 441, right? So 21 times 21 is 441, but now we need to place our decimal, right? How many numbers behind the decimal in the problem? 2. So, how many numbers behind the decimal in the answer? 2. So, 2.1 squared is 4.41. You got that? All right, do letter E on your own. So, what am I gonna write for writing the power as a product of the same factor? 1/4 times 1/4. Very good. And 1/4 times 1/4 is 1/16. Very good. If we did it the other way, okay, if we applied that exponent to everything inside the parentheses, right, we would write, well, let me just delete this. We would write 1 squared over 4 squared, and we would end up with the same thing. Is everybody clear with that? Simple. All right, so for example 6, it says, the zoo has an aquarium that holds 7 to the 4th gallons of water. About how many gallons of water does the aquarium hold? So here, this is 7 to the 4th, which is 7 times 7 times 7 times 7. And then when you multiply that out, it's 2,401. So the aquarium holds 2,401 gallons of water. Okay? Don't forget, when you have a word problem, you must label your answer. Is everybody clear? So let's take a look at got it F. So here, Michigan has more than 10 to the 4th inland lakes. We want to find the value of 10 to the 4th power. So 10 to the 4th power means what? 10 times 10 times 10 times 10. Very good. So that's 10 times 10 times 10 times 10. When we multiply that, what do you get? 10,000. And of course, we're talking about the inland lakes, so this is 10,000 lakes.